matrix, minors and cofactors, right? So what is determinant? Determinant is nothing but for every square matrix, A, B, C, whatever, for every square matrix is associated with a number is called its determinant. So by definition of the determinant, we can write it. Suppose determinants is a function. We can represent it in terms of function. How we'll represent? Suppose f be a function m to k. What is m? M is all set of square matrices. All set of square and what is k here? K is set of all real or complex numbers. So determinants is nothing but a function. You can represent it as f m to k, where m are the all square matrix. So you have to keep it in mind that determinant we can find out only for the case of square matrix. If any matrix is not a square matrix, then we cannot find out the determinant value of that matrix. So determinant value is possible only for the case of square matrix. Square matrix means the matrix chapter we have already learned that what is square matrix. Equal number of row, the matrix which contain the equal number of row and equal number of column, right? So design of square matrix, or better to say order of the square matrix, is possible 1 cross 1, 2 cross 2, 3 cross 3, and so on. But in our syllabus, up to 3 cross 3 square matrix is there, and we will find out the determinant value of the square matrix up to order 3 cross 3. So first, we'll start with 1 cross 1. Let's say A is a square matrix. A is a square matrix having element only 1. First, you have to know that how will we represent determinant for any square matrix. This is the representation of the matrix, and this is the representation of the determinant, right? So for a square matrix, or for any kind of square matrix, it may be 1 cross 1, it may be 2 cross 2, it may be 3 cross 3, or any higher order square matrix. For every square matrix will represent the determinant of that matrix, date of that matrix. That is here named is as A is the square matrix having only one element. Its order is 1 cross 1. So whenever we'll find out the determinant value of that square matrix, we'll write it as date A, or you can write it as, this is not modulus, this is determinant of A, or you can write determinant as this del. So for 1 cross 1, determinant value will be the same, the element value. So here A is a square matrix of 1 cross 1. Its determinant value, the element here is 1. So its determinant value will write det A equals to 1. Or you can write it as determinant of A equals to 1. Now, take one more example. 1 cross 1. Suppose B is another matrix having element -5. So what will be the determinant value? Det B equals to, you can write it also, determinant of B equals to, just put the element value or the element contained in that square matrix, but this is possible only for the case of 1 cross 1. So -5 is the determinant value of that square matrix provided. You have to check whether the order is 1 cross 1 or not. Now, for 2 cross 2, what will be the determinant value? There is one rules. Suppose A is a 2 cross 2 order matrix. So first element will be A11. This is the first row and first column element. Second one A12. Third one will be your A21. Fourth one will be your A22. So this is 2 cross 2 order matrix. For this 2 cross 2 order matrix, whenever we'll find out the determinant value of that 2 cross 2 order, we can write it as det A, or like that, det A, or simply you can write the del. So det A, which is nothing but determinant of A11, A12, A21, A22. There is one crisscross rules. If you apply it, what is that? First, have a look. Multiply of these two elements, that is the diagonal element, minus multiply of these two. Better if we'll color it in a different ink. So first you have to multiply that yellow portion, then minus of multiply of that red portion, right? Now check it. So what will be the determinant value of this matrix? A11 into A22 minus A21 into A12. So this is the basic form. This is the basic form. If we'll proceed to the topic minor cofactor, before that you have to know how to find out the determinant value of a square matrix of order 2 cross 2. This is the base area. You have to know how to find out the determinant value of any 2 cross 2 ordered square matrix. This is the rules. For examples, let's say, suppose we have one, that is B, one square matrix, 2 cross 2 order, that is B. Element content 2, 5, 3, minus 1. What will be the determinant of B? So determinant of B, first write the determinant of that matrix. Then first product of these diagonals where the yellow color is there, yellow color straight line is there, 2 into minus 1, then minus of that red portion, that is 3 into 5. That is the determinant value of that square matrix B is minus 2, minus 15, that is minus 17. This will be your answer. Now, before proceed to the next discussion, for 3x3 order, first you have to know what is our minor, what is our cofactor of any square matrix. Now, start with what is minor and what is cofactor, right? Let's take one example. It will be very much easier for us if we know what is minor and cofactor, then easily we can solve, and this will be very easy to understand how to find out the determinant of 3x3 order. Because to find the 3x3 order determinant, you must have to know and you must have the idea of minor and cofactors. So minor, it is denoted as MIJ, and cofactor, it is denoted as CIJ. So what is minor? For any 3x3 order matrix, this is the base structure, A11, A12, A13, A21, A22, A23, A31, A32, A33, right? You have to know that minor is nothing but the element is in which row and which column. Just we have to leave that overall row and overall column, and we have to omit the overall row and overall column, and you have to take the remaining element. For example, and for minor, you have to keep it in your mind that for every element there will be one minor value. So for this matrix, you can find out minor of A11. What is A11? The minor of A11. For example, M23. This is the minor of A23. So for every element, for a square matrix, for every element, it has its own minor value, and minor value is nothing but one kind of 2x2 order, or for higher cases it will be 3x3 order. So for minor, the order will be always for any for a particular element. Suppose we have one square matrix 4 cross 4 order. So for 4 cross 4 order, we know that total 16 elements will be there. For every 16 elements, there will be one minor value. And the minor determinant, minor is nothing but the determinant structure. So its order will be always one less than the original order. So for example, for any element, for any 4 cross 4 ordered determinant, you are trying to find out the minor value of any element. How will you? What will be the order of the minor? So for every 4 cross 4 order determinant, for every 4 cross 4 order square matrix, or better to say for every element contained in that 4 cross 4 square matrix, every element has its own minor value, and the minor determinant has its order 3 cross 3. 4 minus 1 plus 4 minus 1, that is 3 cross 3. Similarly, for 3 cross 3 order matrix, square matrix, or whenever we will try to find out the determinant value of that 3 cross 3 order square matrix, but first we have to know that what is minor, and for every element we'll find out the minor value. And what is that minor value? Its order will be one less than the original determinant. So for 1 1 element, or 2 3 element, or 3 2 element, for every cases, the order of the minor determinant will be always one less. Here the matrix has, original matrix has order 3 cross 3. So for every element, the minor determinant order will be 2 cross 2. How? M32 is nothing but the minor of A32, right? So let's say for 1 cross 1, 1 cross 1 belong on that row and that column. Just leave these two row and column. Sorry. For M11, leave this column and this row. So what are the element here? The left element is this. So just determinant of A22, A23, A32, A33, right? Now for this is for this. For M23, let's have a look with a different color. For 2 3, first you have to identify the element is here, 2 3, A23. So second row and third column. So you have to omit second row and third column. What are the remaining element then? For m 2 3, the remaining elements are a11, a12, a31, a32, right? So what will be the determinant value? a11 into a32 minus a31 into a12. Here also, if we write a22 into a33 minus a32 into a23. Now, for example, another, take one more minor value. M23. Let's erase these colors. So, M32, that is the determinant value of this M32, determinant value. Let's say M32, that is just omit third row and then omit second column. What are the elements? What are the remaining elements? And write the remaining elements and find the determinant value. A11, A13, A21, and A23. Right? So from the concept of 2 cross 2 order, you can easily find out, you can easily apply the crisscross rule, and you will find out A11, A23 minus A21 into A13. Right? In this way, we can find out the minor value. So minor is nothing but the determinant value whose order is 1 less than the original square matrix order. And for every element, there will be one minor value. And for every element, there will be also one cofactor, which will be our next topic. So in every cases, we can say that what is the order of that determinant? That is 2 cross 2. Original matrix having order 3 cross 3. As you are subtracting one row and one column, so its order will be automatically 1 less than the original square matrix. So here also order is 2 cross 2. Here also order is 2 cross 2. Now, next topic is cofactor. It is denoted by Cij. For example, A is a square matrix. It is denoted as Aij, that is ith row and jth column intersection element. Same like minors, you can also find out the cofactor values. The formula is very simple. Minus 1 to the power I plus j and its minor value, right? So first you have to identify the location of the element, that is at which row and at which column the element belongs to. Then just identify the row and column, just sum the ith row and jth column position, and it will be on power of -1. Then individually first you have to find out the minor value. then just multiply these two. How it works? For example, A is a square matrix. A11, A12, A13, A21, A22, A23, A31, A32, A33. Same like minor, we can also find out the cofactors of every element. So for example, what will be the cofactor value of A22? First, cofactor of A22, write as C22. So first you have to identify the location, that is A22 belongs to second row and second column. So -1 whole to the power second row, that is 2 plus 2 second column into its minor value. So for A22, what is the minor value? That is M22. Let's take one more example. Suppose for A12, what will be the cofactor? We'll write it as C12. Now identify the location. First row, second column element is A12. So this is cofactor of A12, first row and second column. So how will you find out the cofactor? -1 whole to the power 1 plus 2 into its minor value, right? In this way, we can find out the cofactor of every element. Now start with one example. Now, for example, A is a square matrix given 1, -3, 2, 4, -1, 2, 3, 5, 2. So the question is given, this is the question. Find minor and cofactor of each element of the first column. So for this column, what are the elements are there? That is A11, the value of A11 is 1. A21, that is 4, A31. So you have to, basically you have to find out the minor and cofactor of, you have to find, first you have to identify what is your requirements. So you have to basically find out the minor and cofactor of minor and cofactor of A11, A21 and A31. So first find out M11, because minor of A11 is M11. So M11 belongs to first row and first column. So if we leave these elements, for example, this and this, just omit these two, you can get the determinant value of -1, 2, 5 and 2. Now for same way, for M21, first write down the structure. M21, that is for second row and first column you have to cancel. So the remaining elements, if we draw, it, second row and first column. So what are the remaining element? That is -3, 2, 5 and 2. Now the same way for M31, what will be the determinant value? So first just erase these colors. Now draw it. 3-1, that is third row and first column. So left elements are the remaining elements are -3, 2, -1 and 2. Now from the concept of 2 cross 2 order, you can easily find out the values. That is -1 into 2 -5 into 2. Here also -3 into 2 -5 into 2. Here -3 into 2 minus of -1 into 2. So find the values. First case the value is -2 -10, then -6 -10, then -6 plus of 2, because that minus and minus will be plus. -12 -16 and -4. Now what will be the minor value, cofactor values? With a different color I am writing. First erase this and this. Now what are the cofactors? What is the formula? That is -1 to the power I plus j into the minor value. So cofactor of C11, that is C11 value, is -1 whole to the power 1 plus 1. We know that -1 to the power even means always it will be plus, -1 to the power odd means it will be always negative. So for every cases, if first you have to check what are the summation of I plus j. If this will be odd, then the sign of cofactor and minors are interchanging. Value will remain same, but the sign is interchanging. And for the even case, if summation of I plus j will be even, then the cofactor value will be equal to the minor value. Very simple. So 1 plus 1, that is even, into M11. So even for the case of even, if we write it in this way, shortcut trick, or -1 to the power I plus j, if this I plus j is even or odd, if I plus j is even, then Cij will have same value as Mij, and for the case of odd, Cij will be minus of Mij as the value is interchangeable. So minus 1 to the power 1 plus 1, that is even. So minor value will be same as cofactor value. So its cofactor value is also minus 12. Now for C21 minus 1 whole to the power 2 plus 1, that is odd, into M21. So minus 1 to the power 2 plus 1 odd means 1 minus will come and write its minor value. So it will be 16. So minor was minus 16 and cofactor is just interchanging the sides or just opposite of its sign, that is 16. Now C31, it is minus 1 to the power again 3 plus 1, that is even, and you know that for the case of even, the cofactor value will be same as the minor value. So it will come plus and put the minor value, that is minus 4, here minus 2. So this is the cofactor value of this. So this is minor value and these are the cofactor values for first column. Now for 3 cross 3 order determinant, here the matrix, square matrix 3 cross 3 order is written. We have to find out the determinant value of this. Here for this 3 cross 3 order determinant, you have to go along any row and any column. The value will be same for all. If we expand it along any row, the value will come, which value will come? It will be same as anyone follow any other column or any other row, the value will be same. So for example, first you have to choose along which row or which column you want to expand. So my target is along this. This is, sorry, along second row we want to proceed. This is nothing but the way to sum and product. So for this row, first you have to write along row 2 we want to expand it. What is the formula for this row or for this column? This is summation of minus 1 whole to the power I plus j into its element into its minor. And you know that this and this gives us the cofactor. So you can also write it sum of the element and its cofactor also. For this row, you can only apply. So for this row 2, how will you find out? First, you have to write determinant of A. Before continuing, just give a simple idea of this. We can represent it as the Sine Rule. What is Sine Rule? That is for that determinant for 3x3 order matrix for 3x3 order determinant. 1 plus 1, that is even, so minus 1 to the power even is even, that is plus. So better to write in this way. Minus 1 whole to the power 1 plus 1. For this place, minus 1, 1 plus 2. Minus 1 to the power 1 plus 3. Same like that, minus 1 to the power 2 plus 1. Minus 1 to the power 2 plus 2. Minus 1 to the power 2 plus 3. Minus 1 to the power 3 plus 1. Minus 1 to the power 3 plus 2. Minus 1 to the power 3 plus 3. Easy to remind it, we call it as Sine Rule. Minus 1 to the power even, that is plus, minus, plus, minus, plus, minus, plus, minus, and plus. So, determinant of A. Our target is to find out the determinant of A. What is the formula? Summation for a particular along which row and which column you are trying to expanding the determinant and you are trying to find out the value of the determinant, you have to first identify. And along this row here, I have written along row 2 will expand it. So row 2 has the sign starting with minus, then plus, then minus. So if we'll write it here, date A is first sign, that is minus, into the element, that is A21, into its minor value, that is its minor is, just omit this one and this one, we'll get A12, A13, A32, and A33. Then next sign is plus. Here the addition is there. Plus of plus, that is plus. Element is A22, its minor value. So just we have to omit this column and this row. So the left elements are A11, A13, A31, and A33. Then plus of sign, as because this is the summation, so summation of sign, that is minus, here is minus is there, then its element, that is A23, and its minor value, That is, you have to omit that second row and now third column. So the remaining elements are A11, A12, A31 and A32, right? So the value, we have covered all the elements in row 2 and we'll find out the determinant value in this way. Now here one example is given. One 3x3 determinant is given. We have to find out the value of this determinant. Elements are 2, 3, minus 2, 1, 2, 3, minus 2, 1, minus 3. So you have to expand along row 2. How it will works? Here I have already written the sine rule. So you have to follow the row 2 minus, plus and minus 1 is given. So first write minus of element 1 and its minor, that is, if we leave second row and first column, the remaining elements are 3, minus 2, 1, minus 3, plus 2 into, as the sign here is plus, so I have not written here. So 2 into, omit that second row and second column. What are the elements? 2, minus 2, minus 2 and minus 3. Now in that position sign is minus, so minus plus of minus into the element, that is 3 and its minor value. So you have to omit that second row and third column because that place belongs to the second row, third column. So 2, 3, minus 2, 1. So value will be minus of product of 3 and minus 3, that is minus 9, minus of 1 into minus 2, that is minus 2, plus 2 into minus 3, that is minus 6, minus of minus 2 and minus 2, that is plus 4, minus that plus and minus minus, 3 into 2 ones are 2, minus of minus 2 and 3, that is minus 6. So what are the determinant values? Minus 9, sorry, minus 9, plus 2, plus 2 into minus 10, minus 3 into 2 plus of 6, that is how much? 2 first, right? 2 plus of 6, therefore minus of minus 7, here it will be minus 20, here minus 3, into 6 plus 2, 8, 8, so 7 minus 20 minus 24, that is minus 37. So it will be the determinant value of that 3 cross 3 order matrix. So we have expanded along row 2. For example, anyone go along column 3. The value will be same as minus 3. So it will be your homework that expand along column 3. That is, I'm giving you the hints. You have to follow this sine rule. You have to start with this, then you have to take this, then you have to take this. So along column 3, you have to expand and check what values is coming, whether it is same as these values, that is minus 37 or not. Now our next topic is singular matrix. What is singular matrix? As of now, we know that how to find out the determinant of different order, that is 1 cross 1, 2 cross 2 and 3 cross 3 order matrix, square matrix. We know how to find out the determinant value of this square matrix. Now come, what is singular matrix? So whenever you are getting the value, the determinant value of any square matrix, you can check you are getting one real value. Maybe if the elements are complex, you can get also the complex values. So in short, you can get any real number and the complex numbers also. That is imaginary as well as real number you can get. So ultimately, you have to understand, whenever you are solving any determinant, you are getting one particular value, which was not possible for the case of different matrix. Matrix is just one format. You have to calculate matrix multiplication, addition, subtraction, transpose. These all are the different format, one form to another form. But for the case of determinant, you are getting one value, provided you have to check whether the matrix is square or not. Now, which one is our singular matrix? As you know, how to find out the determinant value? Singular matrix is that matrix whose determinant value is 0. For example, I'm taking one square matrix is given 2, 3, 1, minus 2. What is the data? That is 2 into minus 2 minus of 1 into 3, that is minus 4 minus 3, that is minus 7. Check whether the data is 0 or not. Here the value is minus 7. So obviously this is not 0. So you have to write this is not equals to 0. That is, the matrix, the original matrix A is non-singular. Non-singular matrix. Take one more example. B is 1, 2 cross 2 matrix is given. 3, 12, 2, and 8. Find the determinant value. Determinant of B is 3 into 8 minus 2 into 12, that is 24, minus 24, that is 0. So that matrix B is 2 cross 2, it's a square matrix, its determinant value is 0. Therefore, you can say that B is singular matrix, right? Now, our next topic is Sarras rule or Sarras diagram to find the determinant value. You have to keep it in your mind that Sarras rule or Sarras diagram we can apply only for the case of 3 cross 3 ordered determinant, not more than that or not less than that. So you have to keep it in your mind about the order of the determinant which is given. If this one is 3 cross 3, you can apply, and this is very important method. You can easily solve, and no such requirement of minor cofactor in this rule. This is also applicable for JEE. So what is that? Here this is given. Here this is given. I have written all the elements first. This is A, determinant is given 1, 2, 3, 2, 3, 1, 2, 0, 5. Now I have written all the numbers first, all the determinant elements I have written. Then again I have repeated these first and second column parallelly, right? Then identify the diagonals. In the green color I mentioned, you have to find out the product of this diagonal. You'll get the 3 diagonal on each side. This is the first diagonal, this is the second diagonal, this is the third diagonal if we go from left to right. And from right to left, you'll get these red colors diagonals. So what you have to do? You have to find out the product of these elements. So what are the products? 1 into 3 into 5. In the first diagonal, the product is 15. In the first diagonal, product is here 15. Then in the second diagonal, the product is 2 for the 8, 8 to the 16. Then in the third diagonal, 2 into 3 into 0, that is 0. Now just add all these numbers. You will get the value 31. This is our step 1. Then we'll multiply in the same way. We'll multiply these 3 diagonal elements. So in the first diagonal, 2 into 3 into 3, that is 18. Next, 0 into 4 into 1, that is 0. In the next diagonal, 5 into 2 into 2, that is 5 to the 10, 10 to the 20. Now, sum of all these 3, you will get the value 38. Now, what will be your ultimate determinant value? So, det A will be your, first this is our step 1 and this is our step 2. Ultimate determinant value will be step 1 minus step 2. That is, value of step 1 is 31 minus value of step 2 is 38. So the ultimate answer is minus 38. Sorry, minus 7. 31 minus 38 is your minus 7. So in this way you can also find out using Sarah's rule, you can also find out the value of the determinant. So your homework will be for this determinant, you can check for the same determinant. I'm giving you one homework, that is along row 1. This is the first question. Then you will solve it along column 2. Then using Sarah's rule, also check if all 3 values are same or not, right? So this will be your homework. You can easily apply Sarah's rule and you will solve it accordingly. Using Sarah's rule you can also solve. You can follow any row or any column to solve any 3 cross 3 order determinant.